Hi, my name is Neil. I'm a student at UNSW and I'm applying for the API Powerup Scholarship. I'm interested in a career in the Australian power sector as I'm interested in renewables and renewable energy as a whole, and I want to ensure that as we use up more power, we're taking that power from clean sources. My interest in renewables comes down to a philosophy that we should try to maximize the use of resources that we have to ensure that we reduce waste. An example of this is I take things that people would predominantly consider as e-waste and try to fix them into things that are usable. For example, I take old cameras that may be broken and try to fix them so I can get them working again. I have a collection. I'll throw a photo up here. Another example is my home server setup was actually a computer that I found on the side of the road. It was broken, parts were shorting out. I managed to fix them. I used a bit of soldering and I got them working again. And now that server is my home database. I store everything on there. I'm particularly excited about the future of energy and our electricity system, especially our energy grid, in the sense that I'm interested in how we reinforce our energy grid to adapt to our shift to a decentralized network. Right now, our centralized network, we have one major power source or a few major power sources and everything gets distributed out. But as we adopt solar panels, like I said in one of my paragraphs, Australia is actually the largest adopter of solar panels at home. As we adopt the solar panels, we have millions of small power sources that distribute out. And I'm interested in how that distribution network works because the technology behind it is quite advanced and it's very difficult to implement. And I want to see how that's orchestrated. In terms of a learning approach, I find myself to be a hands-on learner. I find it's easier if I have a physical implementation or a simulation. For example, a recent project of mine is this. It's a component identifier I made at university. And the way I created it was that I took my different parts and I just ran different voltages and currents through it until I was able to get boundaries that I could reliably detect components on. And obviously, this process is trial and error essentially. And I ran into problems I had to troubleshoot. But I found that by troubleshooting them, it actually reinforced my understanding of the concepts. So I was able to take the physical part and then convert it back into theoretical. And I find that's the best way that I learn. I'm excited for this opportunity for the API Powerup Scholarship, and I'm excited to work in the energy sector in Australia and to head ourselves into a future of renewable electricity.